For 14, we have, again, something that appears to be exponential because we're given a percent change, percent each day. We're given an initial value, and that it's some crystal that's growing, increasing by 40% a day. Determine the equation that determines the length of L of crystal T days after it starts growing. So we'll go with G for growth, G of T. Well, we start at 3.2 inches long, and what we're going to do is, since it's increasing 40% each day, again, the mathematics is we start, since we're increasing, we always get back what we started with, plus we're getting 40% more, so that's 140% of the previous day. To turn it into a factor, we divide it by 100, which gives us 1.4. That's the factor we use in our formula, 1.4. We multiply by 1.4%, and we'll get the next day, and we do that for each day. So each day we're multiplying by 1.4. So there it is. Solve for the exact number of days that are needed for the crystal to become 10 inches long. Okay, give the exact expression for the value of T. So they want us to use a log expression. We could do this graphically, but it'll probably give us a decimal, and they say don't use a decimal. But we could always check it that way. So anyway, what we want is the output is going to be 10 inches long. So we set G of T is equal to 10. We take our formula, 3.2, 1.4 raised to the T, and what we need to do is solve for T. So what do we do first? Well, first thing is to try to isolate the exponential. So we divide by 3.2. Divide by 3.2. And that's going to give us 10 divided by 3.2. Since they want an exact value, if we divide, what do we get? Do we get something that's not too bad to look at? Do we get something that's, not a repeating decimal? So let's just say 10 divided by 3.2. We could just leave it as a fraction, but 3.125. I think that's exact enough. It's not a decimal that's continuing on. So now it says not a decimal approximation, but we would get that with the log. So we can write this as, let's change back this color. So I'm going to write this as 3.125. 3.2 divided by 3.2 is 1. 1.4 to the T power. This is now where we're going to use a logarithm. So we're going to take the natural log of both sides. And this is where we probably don't want to change that out. Remember, when we do that, what that allows us to do is to take this exponent and bring it down and be multiplication in front. So what we end up with is we get that the natural log of 3.125 is equal to T times the natural log of 1.4. And now all that's left to do is to divide both sides by the natural log of 1.4. And as the reason we do that is because natural log of 1.4 divided by natural log of 1.4 is 1. They cancel each other out, right? Leaving us with T here. And this is what we want to leave it at. So T equals this. That's our answer. We don't want to put this in our calculator. It gives us a decimal approximation. This is as exact as we can get. So that's our answer for 14 using logarithms.